I always like to double check. I'm going to trust that the feed went correct this time. I am. It did. Nice. Cool. So I am earlier than usual, simply because I want to go play tennis later and be outside. It's really nice. But I wanted to make sure I get my study in and do some overview, answer some questions, and at least it'll be on the feed for other people who maybe want to view it later on this evening, afternoon, whatever time frame, wherever you are. So I actually changed the way that I'm doing my notes. So before I was using Notion, which is still really good. But for some reason, I thought doing them in a slide deck might be a little bit easier, especially because I know some people have asked for notes or have expressed like how to do notes and all kinds of stuff. So I thought it was easier to kind of put it in a slide deck that can be shared out, which I plan to do once I finish going through all of the chapters. So I've already done a study session for chapter 1 and chapter 2, which just covered, chapter 1 and chapter 4. Chapter 1 covered just kind of an overview of AWS. Chapter 4 covered networking, but chapter 2, 3, and 4 are kind of in the networking scheme where it was going over compute. It was going over some networking services, which is not my forte, right? Networking is not my strong suit. Like I'm not even gonna lie. So even as I'm going through these notes, I'm like, okay, clearly this is a chapter that you have to go over more often than not. But anyway, we'll get down to it. So the way that I wind up putting these notes together, so this is the book that these notes are based off of. I have a subscription to O'Reilly that I'm using to get these notes. So it's called the AWS Certified Solutions Architect Associate All-in-One Guide. I have another all-in-one guide that I've provided out. It was an older version, which a lot of the information still holds true. The main difference is that so if you know that the AWS Solutions Architect exam changed at the beginning of this year, where I think it had 6 domains and now it has 4. So this book kind of aligns more with the new exam that had recently come out. Of course, there are 4 domains now, like I just said, which you can see here, and the different weights. And then I just started going through each chapter. So the way I broke down my notes is the first is the overview, like that's the name of the chapter. I have some key vocabulary that is part of that chapter. So as I read this first key vocabulary page, I should be able to understand each one of these. So I should understand what cloud computing is, what on-demand is, pay-as-you-go model, regions, XYZ. And then I just go into a breakdown of some of the more subcategories within each chapter. So we had some advantages of AWS, what are the different cloud computing and deployment models, they list all of the AWS services, and I realize how many goddamn services they have. It's a lot, and it's broken down into different categories: compute, networking, security, XYZ. Thankfully, they don't go through, like, you don't have to memorize all of them, but you should know a good majority of them for the exam because they go through a lot, okay? All the services. So today we're going to go into storage. I'm just going to do a quick overview of storage, again, showing you kind of the keywords and then the categories, and then we'll answer some questions. We'll call it a day, and then I'll be back next week or so. Cool. So key vocabulary that I got out of this, and I think I need to add one more, is about object storage, block storage, file storage, what's called S3, which is simple storage service, and then elastic block store. With simple storage service, they have some of the advantages is that it's unlimited storage, there's no cap. It is a regional service, which means that you have automatic replication across different availability zones within a region. It is scalable, durable, supports encryption, high performance, high availability, 99.999% of the time, and pretty cost effective. Some of the most popular use cases for using S3 is popular for backups. It's a good replacement for magnetic tape. You can use it for static web hosting, which I thought was really cool. So if you have a website that you want to put up where not much information is changing that often and you kind of just want to put it out towards the internet, you have that. Good for disaster recovery, content distribution, if you're creating a data lake, private repository. And then it's categorized as a write once, read many times, which means this is not a service if you plan on having high write, if you're writing to it a lot, which means that you just you're creating a lot or you're changing this page pretty often. The reason why is, again, it was for static website hosting, and static means it's not changing. Like, you're not doing a lot. This is not a website, or this is not a page that you're updating pretty often. So that's why it says write once, read many, where many people can view your page, but not necessarily write a lot to it. Cool. Some more characteristics. I learned that it was an eventual consistent system, which is definitely a question that you come across, which can be kind of confusing sometimes. So like, it'll be a question where it'll say, hey, what happens after you delete something or after you create something? Can you like see the data right away? And with eventual consistent systems means that there's going to be a delay. So there's something called like a put, a list, a get, XYZ. There are certain, what do you call that? Variables, I guess, or actions that you can do towards like file systems or like a simple storage service, right? So as you put to something, that means you are kind of pushing out information to that, we'll just say one of your buckets that you have, or if you're deleting something, that's pretty self-explanatory. If you're listing, that's pretty self-explanatory. You're listing all the different files that are in there. But they'll have questions about if it's an eventual consistent system, that means that the information that is being pushed isn't automatic. So like, especially when it comes to replication across different availability zones. So if you push, if you say, for example, you have a file that you would like to, or you have something that you need to be redundant across different availability zones within a region, and you put to one, eventual consistency means that it will eventually get to the other two. If you have three, it will eventually get to the other two, but it won't do it right away. So if you try to maybe read the information from a different availability zone, or you try to read the information right away, you might not see it. You might get an error simply because eventually consistent means it'll eventually get there. Pretty self-explanatory, but there are questions that trick you. I've definitely seen them on the practice exams that we do on Sundays. If you are going to, they had a best practice. So if your put, list, or deletes per second is exceeding 100, there's some different partitioning best practices. I didn't put them there because they were very specific for that use case. And I haven't seen questions, as I'm doing practice tests, I haven't seen any questions regarding that. But they did have some best practices, and at least it's something good to know. So like, if there might be a question that asks, well, what is the limit for exceeding per second before you have to maybe do something else? It might be something like that. It uses server-side encryption to automatically encrypt data, using AES 256. And then they had different kinds or different types of encryption. So we had the SSE, which means Amazon will encrypt at rest and they manage the keys. You had SSEC, which stands for customer, which means that Amazon will encrypt, but the customer, you, will manage the keys. And then you have KMS, which just means you're using their key management system to manage the keys. So it's just really understanding the different encryption key management systems, like whether or not you want to manage it, whether or not you care about Amazon managing it, or whether or not you want to just have it in your key management storage. Some security best practices is to make sure that your buckets are not publicly accessible unless you explicitly would like them to be. Make sure you use least privilege, enable multi-factor authentication, make sure you audit your S3 buckets, and then make sure you're using IAM roles when you're assigning permissions. So there are some different storage classes, which is really good to know, especially as you go through the lifecycle management, because there will be questions that ask, well, what kind of action set would you put together if, for example, you have a file that you need to retain now for the next 6 months, but after that you need to retain it for 7 years? What kind of storage class would you put in place, right? Would you keep the standard, or would you maybe move to infrequent access versus Glacier, right? And then within that, how quick you have to understand available to you depending on which storage class. So the default is the standard storage class. Then you have infrequent access, which is cheaper than standard. And as we go down, each one gets cheaper. But as your storage classes get cheaper, how quickly you can access the data gets longer. And yeah, I think that's really one of the biggest differences is like as you go down the list, it's more so so for example, with Glacier, right? Their data archiving, and that's a keyword. Archiving is a keyword when it comes to storage class. If you ever see archiving, automatically think Glacier. So when it comes to archiving, you can get it in a couple of hours, a couple of minutes. If you get it in a couple of minutes, that's going to cost you a lot of money compared to if you maybe just kept it in cheaper. If you had to do it, maybe you had to keep it for a couple of months. It might be cheaper for you to just use this version rather than Glacier. So definitely make sure you go through the different storage classes, make sure you understand what's happening there, and make sure you understand price points. You don't need to know like exact dollar amounts, but you need to know which one's cheapest, which one's most cost effective, and how much it will cost you if you need to get that data back into play. I want to say rehydrate, but that's simply because of my job. My job has a feature called rehydrate, which I think is a really good word, a really good term to call when you're trying to recall data back into your system or back into your feed or whatever it is that you have. You kind of rehydrate things. I like that word. So kudos to them for creating that. So yeah, again, lifecycle management. And then you have replication, different replication standards. So cross-region replication means that you can copy an object, which is a file, across different regions, or if you choose to only copy across the same regions, maybe you can't have it leave a certain region like the United States. Maybe you can't have your data leave Europe, wherever you're located. So just understanding, again, the different storage classes, lifecycle management, and the different characteristics of S3. Then chapter 2 goes into Elastic Block Store. So Elastic Block Store offers persistent block level storage for EC2 instances. You can attach multiple volumes to one instance. And by instance, I hope you know that an instance is a virtual machine. So you can attach multiple block storage to a virtual machine, but you can only do it per server, unless you're using something what's called a multi-attach. A multi-attach is a separate entire service that allows you to attach multiple storage volumes to a virtual machine. But I think you have to contact AWS for that. So I don't think they would put that on the test, but it's a good to know just in case anyway, like it's possible. You can run multiple type of workloads within this block storage. So you can do databases, applications, big data, NoSQL. You could do websites, all that kind of good stuff. It can be used as a boot partition, and you can create point-in-time snapshots and replicate it for a new block storage. So say, for example, you attach a block storage that has a bunch of data in it, maybe you picked an operating system, like all kinds of whatever the case that you may be, and say you want to use that point in time as a way to create other volumes going forward, you can create a snapshot. That snapshot can then be replicated to go ahead and create new volumes. Some features, let me move that. How do you move that? Nope, go back. Cool. It's persistent storage, general purpose, high availability and reliability. Most of the services have high availability and reliability and durability. I want to say that. I'm fairly certain that most of them have the 99.999% uptime. It supports encryption, of course. It can only go up to 16 terabytes, and it's easy to use and resilient. What else? You have something called an instance store, which is the local storage for an EC2 instance. It cannot be mounted to different servers. It's ephemeral, which means that once you shut it down, your data is gone. You can't use it for snapshots, and it's available in SSD or hybrid HD. So with Elastic Block Store, there are different types. I listed out the main 3 types that I saw, and within these 2, they had a couple of different ones, even like they dig down even deeper. But I personally got the ones I thought would be most relevant, like the ones that had a lot of use cases, because I figured that that's what that's what would probably be on the test. So really understanding the different aspects of SSD versus HDD and understanding throughput. I did see one of them that was asking, well, if my input output, is going to be 10,000, what can I use? So this, for example, if this can go up to 16,000, this might work for that. But say if I have something that needed 20K input output, clearly that's not the answer, right? So maybe I would have to do something else. Maybe I'd have to figure out what other service might help out. All right, Elastic File System. I should drink some water, shouldn't I? I'm out here. Hold on. Elastic File System. It acts as a local file system when attached to an instance. You can mount the same file system across multiple instances. That's also key to know as I'm going through a lot of the services, understanding what complementary service can be attached to multiple instances versus when you can have a one-to-many versus a one-to-one. That's a better way to put it, especially as you start deep diving into what it means to be an architect in terms of if I have regional locations, I have, users across the world, I have users in certain places, like really understanding what services are regional, what services are zonal, what services are local, like understanding where you need to place your data and what services can allow you to best fit the needs of your users has been pretty key as I'm going along studying for it. Some attributes of I'm about to say electric, of an Elastic file system. It's fully managed. It has the same semantics or expectations as a regular file system. So it's really no different. It has shared storage, which means you can, again, attach it to multiple instances. I don't know why I put Elastic again, because it's called Elastic File System, but it's Elastic. Scalable, again, performance across a variety of workloads, similar to Elastic Block Storage, highly available and durable. All right, now say you have, which is the case for many organizations, going forward, hybrid is going to be pretty key, simply because there are many companies who aren't able to be fully cloud native. And in that case, they're going to have some on-premise needs. So understanding what services can help with hybrid integrations. So on-premise storage integration with AWS. You have AWS Storage Gateway, which can be deployed as a virtual machine in your existing environment, which is like on-premise. And then you can connect to AWS pretty securely, for storage application uses. There are 3 storage interfaces. There's something called a file gateways for you to, of course, store and retrieve files. There's a volume gateway that acts as a disk volume using iSCSI. I pronounce it iSCSI. I know people pronounce it different ways, but when I first started getting into stuff, I heard iSCSI, so that's what I've been saying. And then you have tape gateway for backups. You have AWS Snowball, which is another service. I need to put that in the keywords, so I need to go back and make sure I'm highlighting more keywords. So you have AWS Snowball, which is an import-export tool. It does petabyte data, which is important to know, because again, a lot of the questions will say, okay, if I have something that needs to support terabyte, if I have something that needs to support petabyte, like you need to be able to know which service allows up to what kind of data capacity. So they have two options here for Snowball. You have 50 terabyte, 80 terabyte versus Edge, which is the same thing. It's still an import export tool, but up to 100. So say, for example, if one of the questions say, oh, well, I need 105, right? You can't use this one. You would have to use Edge. And then Snowmobile, who comes up with these names? I just want to know, product team, like who's doing these naming conventions? Product team is an exabyte data transfer service, which is connected to your local network. If I'm not mistaken, I think they actually go with this version. Amazon actually, is it this one where Amazon goes to your data center? I want to say so, where they connect something to your data center and that's how you're connecting back and forth. All right, that was chapter 2. I'll briefly go over chapter 3. And I say briefly simply because I didn't finish putting on my notes there, but I'll go over what I have thus far and then we'll jump into some questions. Easy peasy. So chapter 3, and chapter 3 here, so chapter 3 in this book corresponds with chapter 4 in the other book, which is about networking. I don't mind going over it again because again, networking is not my forte. It is why I failed the Network Plus exam and I did not go back and take it again because I don't need it. I ain't out here trying to be a network person. Like I need to understand the basics of networking, which I do. But because I don't use it in my day-to-day, it's not something that's pertinent to my success in my role, so to speak. I forget a lot about it. Like I'm not architecting a network. I'm not doing any of that. So I don't mind going over it again. So within here, there's a lot of keywords. Like like I said, I'm not finished with this section, but it goes over VPC, CIDR, IPv4, like the different subnets, internet gateways. I'll go through each one of them. This is what I got up to was the transit gateway, I think. So some VPC concepts. A virtual private cloud allows you to, VPC stands for virtual private cloud. I should write that down. It allows you to logically isolate a section of the cloud. The first step in creating a VPC is always deciding your IP range via your CIDR, like figuring out your IP addresses. An IP4 version 4 address is required, whereas version 6 is not, it's optional. And hello, sorry, I have a question. Are these slides going to be available on your website? They will. Okay, so they will, but my website's under construction right now. But I will figure out a way to get this out to everyone. So for right now, I will link it on my social media. But right now I'm revamping my website because what I would like to do is create a bunch of series of these study groups or these study sessions and put all the information in there. So actually what I will do, what I have already created is I have kind of these folders. So I have an AWS Solutions Architect folder and that has these slides. It has all the videos that I'm doing. So what I can do is I can share that out, but I am going to put this all on my website once your girl gets some time to like revamp it. So I will make it available for everyone. And I'm a perfectionist where I need to make sure I have all the information right, but I will make it available. I'll share it out afterward, after this. What was I saying? Yes, version 6 is optional. You cannot alter a VPC once it's been created. So one of the notes that they had, or an exam tip that they had in the book, no problem, thank you. One of the exam tips that they had was that once you create a virtual private cloud and you realize later that, oh, you didn't make it big enough, like you need more spaces, then you have to create a brand new one. And then you just have to transfer your application and your assets to that new virtual private cloud, which can be annoying, right? So it's really good. And like sometimes like there might be a use case where you just, that kind of just happens. But it is really important, especially if you're someone who wants to get into networking and get into architecting, to really understand and thoroughly understand your environment beforehand. Because imagine you might be in a company, this chair is like miles away. Imagine if you're in a company that has thousands, like you create such a big architect that spans regions and a whole bunch of zones, and you've created all kinds of routes and you like set everything up just to realize that you have to do that all over again. is annoying. Now, I'm not sure if there's an easier way to like copy and repeat and just make things bigger when it comes to that. But a key part that they put, again, an exam tip, is that once you create a VPC, whatever size you pick, you cannot alter. So keep that in mind. Also, VPCs are regional only, which means they cannot span multiple regions. So this is just an example that they had in a book that I was able to copy and paste that are just showing. So this is a region, and within this region, we have 3 availability zones, and then you have a router that's kind of sitting there. So this is just an example, like a high level example of a virtual private cloud and showing you the different zones in a region at XYZ. Some subnet concepts, and listen, subnets, you know that, I don't know, well, y'all probably know, because if y'all are coming here from Twitter, I'm pretty sure you have seen the meme of the white man blink, right? Subnets make me white man blink because it's a lot. Like, I need to put I'm gonna put the meme, I'm gonna attach it in here on the slide page to show you to demonstrate how I'm feeling every time I come across subnets, because calculating this and remembering this and then remembering that the first 4 and the last IP and how many, I don't want to do that. I don't like math. That's why I'm not into networking. I don't do that. So anyway, some common subnets. Of course, you have public, private, VPN only. Pretty self-explanatory. Public is for the internet. Private is for internal. VPN only is to connect your VPC with the data center. Some key tips that they put in the book as well is that if you are asked about, so there's different tiers. If you're asked about something called a web tier, which means you have a web server because it's out to the public, that's always going to be associated with your public subnet. If you have a database, you always should put that in your private subnet. CIDR blocks, the smallest that they listed in there was the /28 versus the /64. I don't even think gazillion is actually a real term, but the amount of numbers that they had listed there was beyond the scope of my knowledge. And to me, it seemed like a gazillion. So let's just say it's a lot. Okay, like that's how many the /64 was. It was a lot. Another characteristic is that you can have one subnet per availability zone, but you can have multiple subnets within that availability zone, which means it's not regional, right? So I've talked about a little bit earlier about having regional versus zonal services and really understanding which ones are which, because a subnet is not regional, which means you can only have it within an availability zone. And let me come back here. So imagine, so again, this really big outer part is your region. Your inner part is your availability zones. There's 3. Now imagine if I had another one of these, like if I just doubled this picture and I had 2, right? So I had 2 regions that some of my assets are spanning across. My subnet cannot span across those 2 regions. It can only span within one availability zone. But within one availability zone, you can have as many subnets as you want, but that subnet cannot span from zone C to zone B or all that kind of good stuff. Anyway, really complicated, but just understand which services are zonal, which services are regional. This is not a regional service. This is a zone. I call it zonal. It's a zonal service. And then again, a key point to understand is that the first 4 IP addresses and the last IP addresses in any subnet is always reserved for internal resources for AWS, like for Amazon, not for you, but for Amazon, which means that, again, it's key to understand how many address spaces you need, because if you say, oh, say in total you need 15 IP addresses, and you say, okay, well, this CIDR block fulfills my needs, right? It has 16, I need 15. You don't have 15 because actuality, 5 of them are being taken, which brings your number down, which means this no longer suits your needs. So if you've already created your virtual private cloud, if you already created your network with this and you realize, hey, I don't have enough addresses for all of my devices or whatever I'm trying to do, now you're a little bit asked out and you have to start over and then create a brand new one and maybe go to the next CIDR block. So To save you some headache, always make sure you understand how many actual, or like an estimate of like how many actual addresses you need. And that into an estimate, again, that takes into account you having to talk to the business or you having to talk to whoever and really understand, well, is my network going to grow within the next year? How can I anticipate where we are? Just so that way you make sure that you're creating your network correctly. Again, you could have up to a gazillion. Route table. Route table is a table consisting of certain rules that determine where your traffic is directed. You can have multiple subnets associated with the same route table. Route tables are automatically, well, let me come back. A main route table is automatically created for you, but you can create custom route tables and use that instead. So say, for example, the main route table just doesn't suit your needs, it's always recommended. It's always like a lot of the services have some defaults created for you just to get you started for people who maybe just need to get up and running pretty quickly, or maybe they don't quite understand the product, or they don't really understand AWS and they, just want to get started. That's when you would use a lot of the default. So a main route table would be like a default. But if you do understand your environment and you do understand that you need something that's a little bit better, then you can go ahead and create a custom route table. But it's always recommended, they say an exam tip, that whenever you update your table to add like an internet gateway, which is something that I'll get into in a second, or if you add anything to your route, you have to make sure you update your table. In your table, so this is an example of a route table. You're going to have a destination and then a target. So your destination specifies an IP range directed towards your target. And then your target, of course, is where your traffic is directed. So if I did my studying right, I should be able to explain this route table to you, right? So here we have a address block, a CIDR block that is local. And when you see local, that means, sorry, I'm just trying to get something off my screen. So when you see local, that means the traffic is being directed just internally, cannot reach the internet. So both of these, the difference between both of these, this is IP version 4, and this is what IP version 6 addresses look like. Keep in mind, again, the difference between these two, because you might see, I'm gonna get into this in a second, but keep in mind what a IPv6 would look like, just so that way you can differentiate between the two. But it's pretty easy because this has the standard, 10.0.0. whatever, whereas IP version 6 looks like a hot mess. I ain't even gonna lie. I know there's some breakdown as to why it looks like this. I do not know it, but it's a hot mess, and that's how I recognize that that's version 6. I'm like, okay, you don't have the standard convention as version 4 does. You're IPv6. Don't do like me though. You should know what all that stands for. So within this one, this is another IP version 4 address, which is being targeted to a peering. So PCX, the P is for peering. So there is a peer connect. You can peer, which means you are connecting your virtual private cloud to another virtual private cloud, whether or not you own it, your prerogative. But whenever you see a target that kind of looks like this with a P, that means that this traffic is being directed to a peering virtual private cloud. Now, this 0.0.0 means any traffic. It's target when you see IGW. So it's important to know the acronyms of things because it will help you go a long way. So IGW is the Internet Gateway. And what this does is this means that all of this any traffic is allowed to go to the public. And then if you have this, which is an abbreviation for IP version 6 IP addresses, and what this does is these two dots represent, ooh, don't fail me now. These two dots represent, I think, zeros. So like if you see how this version 4 is 0.0.0.0. If I'm not mistaken, somebody can correct. Version 6 doesn't write out all the 0.0s because it tries to save space. And therefore, if you see these double dots, that means it's zeros. Somebody correct me, but I'm pretty sure that that's the reason why. But anyway, both of these are the same. What this says is that any traffic is going to an internet gateway, and that this IPv6 traffic is going to an egress internet gateway. Now, both of these are internet gateways. The key differentiator between these two is that an egress internet gateway is just outbound traffic versus an internet gateway that might do inbound and outbound traffic. So it is important, again, to really understand that not only the differences between internet gateways or the differences between some of these services, but also understand the acronyms, right? Because if you don't know what IDW stands for, you might be lost on a question, because I have seen questions where they just give you a route and they're like, based off of this route table, where's this traffic going? Is this traffic going outbound? Can traffic come inbound? Like, girl, tell me what's happening here. So you will see something like that. Internet gateway. Oh, there you go. Internet gateway allows VPC to communicate to the internet. Pretty self-explanatory. Then we have network address translation. It forwards traffic from private subnets to the internet and sends a response. What this really does is it replaces your IPv4 address with the network as address translation address, which means instead of so from your virtual private cloud, if you do not add an internet gateway, you cannot talk to the internet. Like, your instances are not going to be accessible via the internet. Now, the reason why this is important is because, say you have a database and you need to, because remember, when you create databases, when you create instances, when you create any of this stuff, you need to make sure that you are updating it and that you're patching things and that you're doing best security protocols, right? You can't just create things and have it stay at the same version throughout the entire life cycle, because you might be introducing vulnerabilities that you might not know is there. And then if you don't update them, something might go down. So anyway, if you do not attach an internet gateway, what you can do is use a network address translation that will forward traffic. And it gets a little complicated here once network address translation comes through and you start to see some of the network architects that they have. But you can attach a network address translation device, and that will forward traffic from your private subnet to the internet, and it won't show or won't display that internal IP address. It translates it. So again, this is just a translation for your IP addresses in order to be able to talk to the internet. A key point here is that NAT can only be used for IP version 4 traffic, and that there are a couple of different types. You have NAT instances, which is just your instances is just, that's just your instances that are trying to connect to the internet. So for example, I just said like a database needing patches. If your database needs patches, your database is the one that's initiating, like it would be considered a NAT instance, because that's what's initiating this translation in the first place. And then your NAT gateway, you can have a NAT, or you can have what's called a NAT gateway. So the reason why I put this is that it's preferred to use a gateway over an instance, because an instance has a lot of limited capabilities. It is important for some use cases, but for the most part, best practices is always to use a gateway. You get a bit better availability, bandwidth, failure, but it does need an elastic IP address, which I think I go into a little bit further down. And then you have EIG, which is egress only internet gateway, which again allows VP6 to communicate to the internet, which is what we saw here, EIG. I don't know why they put a W there and not here. So that's what I thought. I'm pretty sure IDW stands for internet gateway, but what I noticed in the book is that they would put IDW here, like here on the routes, but not when they were referencing it, which is weird. All right, I think we're getting towards the end, because I don't think I have, yes, it's the last two because I didn't get far. We have Elastic Network Interface, which allows you to create network interfaces and attach them to your instance. Here are some different attributes to recognize an ENI. You also have Elastic IP addresses, which I was just alluding to before with the network address translation for the gateway one. The difference, but the key to know about Elastic IP addresses is that it's static. And then I put, and then it's used for version 4 and it's public. And then lastly, we have security groups and NACLs. I call them NACLs, network access controllers. But there are some main differences between these two, but just a quick overview. Security groups is a virtual firewall assigned to any instance. It is stateful, which means that any traffic that goes out can also come back in. So if you have port 80 open and you got traffic going through there, then there's going to be traffic coming back. It consists of IP addresses, a port, and a protocol. This is a default. Remember, I was talking about defaults earlier. So this always comes, every VPC you create comes with a default security group. Make sure you create your own, because sometimes, again, these security groups are the defaults that come with a lot of these services. Just might not work for you, right? It might have some things that are open, or it might block some things and you might not know why. Most of the times, if you create a VPC and you realize that some of your traffic is not going where you expected, or just you're not seeing anything, most likely you need to kind of check your security groups. They had some caps, so you can only create 500 security groups per VPC, and then 50 rules each group. And then you have NACLs, network access control lists, which is also another layer of security. It acts as a firewall, but it's at the subnet level. So this is at the instance level. Security groups are at the instance level. NACLs are at the subnet level. Also, NACLs are optional. You do not have to have a network access control list. You do have to have a security group. Like that's, well, again, it's created for you by default. So whether or not you want one is going to be there, but you don't have to have a network access control list. That's totally up to you if you want to have an extra layer at the subnet level, like totally up to you. A key difference between NACLs and NACLs and security groups is that a NACL is stateless, which means that the inbound and outbound traffic is decoupled, versus where stateful means that like your outbound and inbound traffic is the same. Like I said, if you have port 80 open outbound, you have port 80 open inbound. But in network access control list, if you have port 80 open inbound, it doesn't mean that it's also open outbound. You can have it closed outbound, or vice versa, however it is that you want to create it. And it does allow both allow and deny rules, whereas security groups really do. You can't explicitly deny something. You allow something, and then it just denies all other traffic. Versus network access control lists gives you a little bit more granularity. You can say, I want to explicitly allow this, and I want to explicitly deny this. So network access control list goes by number precedence. So the higher the number, the more precedence it takes, versus security groups, which goes through rules, right? So if you've ever seen a set of firewall rules, all of them will be evaluated. And then, like I said, whatever is at the top will go through, and whatever's at then everything else is denied. So say, for example, I want port 80 open, I want port 443 open, I want port 53 open. Like I want these, we'll just say a list of ports open, and then everything else is going to be denied. So it's important to know the differences between a security group and a NACL, and then really understanding where is this applied. One is applied at the instance level, one is applied at the subnet level. Cool. I think that is the end of those two chapters. So again, I have created this for a particular book. I plan on doing every single chapter this way. So every single chapter is going to have some key vocabulary terms, and then it's going to break down each term with hopefully associated pictures if it has some. And this is what I'm going to be using to study and go through. I find it a little bit easier. And again, I think just easier for me to share, because I know some people are interested in figuring out a study resource and a study guide. So let's get into some questions. Hold on, let me stop sharing real quick, and I'll switch over to my question screen, and then we can answer some questions about what we just learned, which I hope we can, because, I spent all that time learning. So let me see. Bum, 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 bum. Cool. Where can I write these questions down? I should say, where can I write my answers down? Why are you playing with me? Single. Okay, cool. Let's share this back. I'm trying to figure out where I'm gonna write my answers. Like on my screen, I have 2 screens. Okay, hold on, let me do this. Let me figure this out. Okay, I'm gonna put them in the notes because I don't know where else to put them, which means my screen's gonna be covered, but that's okay. That's okay. Okay, cool. Oh, but I want you guys to see. Okay, I know what I'm gonna do. I know what to do, Dominique. As you can see, I have no problem talking to myself. Let's come to certifications, not CISM. I'm also studying for my CISM at the same time, which is Chief Information Security Manager, because I like to torture myself. So that's also pretty, it's not intense because honestly, it's really similar to the CIS. And Mary told, well, I'm gonna say Mary, but a friend told me that it's really similar to CISSP, which it is. Okay, what did I do here? I did chapter 4. Let's just do this. I'm gonna create a new page. Cool. We're gonna say this is what chapter, it'd be nice to spell, Dominique. Chapter 2 and 3. We might not get to chapter 3 questions, but that's okay. I can share them out or figure out another way to do that. Cool. So review questions. Let me make this bigger so I can see. Cool. Number 1, in what ways does Amazon Simple Storage Service, which is S3 object, differ from block and file storage? Choose 2. Off the back is a choose 2, and I hate choosing more than one answer. So Amazon S3 stores data in fixed block sizes, which we know is not true. Objects are identified by a numbered address, maybe. Objects can be any size, which is true. Objects contain both data and metadata. Ooh, I don't know. And objects are stored in buckets. Shit, there's 3. There's like 4. Okay, so I know E is definitely one of them because objects are stored in buckets. That is definite because that I remember them saying that in the textbook. It's the second one that I'm a little bit confused at. So objects contain both data and metadata. I do not recall that. I actually read the chapter this time. I do not recall that, but I do recall that it can be any size because there's an unlimited cap. So I want to say B. We're just going to go with it. This is why this is a practice test and not the actual exam. Which of the following are not appropriate use cases for S3? Choose 2. So you can store web content, which we know you can. You can store a file system mounted to a EC2 instance. No. For backups for a relational database, yes. Primary storage for a database, no. Or storing logs for analytics, yes. So I'm automatically going to go with, it's not a file system because they already have a file storage system. And I wouldn't use it for, oh wait, would you use it for primary storage? No. No, no, I'm gonna say no. Because I know you can do backups. I literally just talked about this, Dominique. B and, what did I just say? D. Yeah, yeah, okay, cool. Why is all of them choose 2 or choose 3 answers? What the bumba clock? Okay. Number 3. What are some of the key characteristics of S3? Choose 3 answers. So all objects have a URL. Yes. It can store unlimited amounts of data. Yes. They are world readable by default. No. It uses REST. Yes. And you must pre-allocate. Okay, cool. So I got my 3 answers because I remember them from reading. So all S3 objects do have a URL. You can use unlimited amounts of data, and it does use the REST API. A key point to know about the difference between using REST. So all of Amazon services are depreciating and using SOAP API, which is a key point that they point out. So understanding that S3 buckets use REST APIs instead of SOAP is good to know because Rest is more secure. Number 4. Ooh, number 4. All right, cool. Which features can be used to restrict access to S3 data? Choose 3 again. So you can enable static website hosting on a bucket. Wait, what? Which features can be used to restrict access? Enable static website hosting on a bucket, create a pre-signed URL, use an access control list, use a lifecycle policy, or use a bucket policy. So enabling static website hosting that has nothing to do with restricting. So I'm gonna go, you have to choose 3. So I'm gonna go with definitely about using a bucket policy, definitely about using an ACL. I don't feel like lifecycle policy applies here because I feel like when I wrote lifecycle policy, that was in regards to storage classes. And storage classes don't restrict information, it just moves information. Yeah, so I'm gonna go with B, C, and E. And we're gonna pray on it. All right, number 5, your application stores critical data in S3, which must be protected against inadvertent or intentional deletion. How can this data be protected? Choose 2. So they said that they want to protect it against deletion. You can either use cross-regional replication, you can set a vault lock, you can enable versioning, you can use a lifecycle policy to migrate data to Amazon Glacier, or you could enable MFA, delete on the bucket. Okay, so you choose to protect it against inadvertent or intentional. Okay, so if I'm trying to protect it, so this doesn't, A doesn't really, it makes it redundant, but I wouldn't say that that's a protection mechanism. I'm not sure about vault lock. Enabling version doesn't really protect it either. Because I mean, sure, say for example, you create 4 versions. If I delete one version, I can go, that doesn't help it because then what if I make changes on version 4? If I delete version 4, that doesn't help me because I can bring back version 3, but I don't have those changes. So no, that's out too. A lifecycle policy to migrate data to Amazon Glacier. So how many do I have to pick? 2? All right, so I am leaning towards B and E only because those are the real 2 protection mechanisms. All the other ones have to do with like lifecycle policy. I mean, again, I'm moving my data, but I'm not really protecting it. So I'm gonna say, I don't feel like, I don't remember reading about vault lock though, so I don't feel like that's a correct answer. All right, 6. Your company stores, how many questions are there? 20, goddamn. Your company stores documents in S3, but it wants to minimize cost. Most documents are used actively for about a month, then much less frequently. However, all data must be available within minutes. How can you meet these requirements? So this is an example of a question where I was like, understanding the speed of your different storage classes play a part, or I mean, is important. So they want the data available within minutes, but they want to minimize cost. These documents only be actively used for about a month and then much less frequently. Cool. So migrate the data to reduce redundancy storage after 30 days. Migrate the data to Glacier after 30 days. So I automatically want to say no to Glacier. Oh wait, no, you can. Okay, I'm gonna keep going. Migrate the data to S3 standard and frequent access after 30 days and turn on versioning, then migrate. So versioning, versioning I don't think makes sense here because, yeah, versioning doesn't make sense to me because if I'm versioning something, that means I'm just creating different versions of the same, like if I have changes or I'm just keeping different copies, but that doesn't really help with minimizing costs. So if data needs to be available within minutes, I forgot what reduced redundancy storage is. There's so many goddamn storage classes. And the problem I'm having with Glacier right now is that Glacier, yeah, so Glacier is out simply because Glacier takes a long time to, I'm gonna call it rehydrate. So it takes a long time to get your data back from Glacier, but there is a version that you can use of Glacier to get it back really quickly, but it's not cost efficient. It will cost you a lot of money if you wanna get your data back within minutes versus a couple of hours. So I'm leaning towards C, which is do it to infrequent access, because infrequent access is cheaper than standard, but allows you to get it pretty quickly. As they said, they only need it in a couple months. I just can't remember what reduced redundancy storage is. I'm gonna go with C. We'll see. All right, number 7, how is data stored in Amazon S3 for high durability? Is it automatically replicated to other regions, automatically replicated within a region, replicated only if versioning is enabled, and automatically backed up on tape and restored if needed? So D is out. It does not automatically back up on the tape and restore. Shoot, S3, it was a, shoot, was it regional or zonal? God damn it. I can't remember. But I do remember something about versioning too. I just showed you guys all these notes and I forgot it already, like on the spot. What is happening? Okay, S3, regional or zonal? Regional or zonal? I want to say it is regional because I feel like you can, it's used for, if it's used for static website and so many other things, it would be stupid for it to be zonal because that doesn't make sense, especially if it's cheap. So I'm going to say it's regional. Now, if it's regional, replicated only if version is enabled on the bucket. So that's true, but I don't think that has anything to do with high durability. So I'm going to go with A. C, process of elimination. Like if I can't, like, so that's maybe a way that, I don't know if you recognize the thought process I just did with this, right? So with S3, I could not remember if it's regional or zonal, right? Which I said is pretty important to know for services because you'll have questions like this. It'd be like, how does high durability play a role in this service? Or is this service, does the service have high durability? Because if it's a service that is not regional and it's only zonal, or if it's not zonal, like if it can only be within one availability zone, how are you going to get durability within that, right? So I couldn't remember if it's regional or zonal, but what I can remember is that S3 is used for a wide variety of things. It's used for backups, it's used for static web pages, it's used for so many different things. So if it's used for that many different things, I can't imagine that it would just be a zonal resource, because it just, to me that just doesn't make sense. As a cloud service provider, if I make something that that can be used that variably, and then I don't allow it to be replicated across different regions, that I think would be a major problem for my customers. So that's how I wind up getting to A. I remember some characteristics about a service, even though I couldn't remember if it's zonal or regional. All right, number 8, based on the following URL, which of the following statements is correct? So based off of this URL, which is HTTPS, can I make it a little bit bigger? Yeah, I hope you can see that. Okay, cool. So based off of this, what did they ask me? Which of the following statements is correct? So what I see is that this is the bucket name, this, and then this is the actual name of the file. This is the name of the folder, the file, or like the folder that the file is in, and then this is the name of the bucket. So the object my file is stored in the folder fx in the bucket. Oh, that's easy. Yes. The object my file is stored in the bucket. Oh, did you just take out the folder? The object folder is stored in the bucket, or the object my file. Oh, I see how you're trying to trip me up, because what is considered an object? Holy shit, I remember seeing that too. So an object is not necessarily just the file. I think it's also the name of the file in the folder, like C. It's either C or A. So as I read this exactly how this is listed, where it says my object, my file is stored in this folder, which is stored in this bucket. Like this is the name of the bucket. But is this the whole object, which means that this object is stored in this bucket, which is C. Dang, Dominique, you're gonna have to any, mini, money, mow it. I really any, mini, money, mow in my head. I'm gonna go with C. I don't know, that's a trick. I'm gonna go, I feel like it's not, I feel like my gut is saying no, girl. Shit. No. I'm gonna go with C. I feel like I shouldn't go with C, but I'm gonna go with C anyway. We'll see. Again, this is a practice test. Okay. Or practice chapter review thingamababa. Okay, to have a record of who accessed your S3 data and from, what should you do? Should you enable versioning? No. Should you do website hosting? Doesn't make sense. Enable service access log? Sure. Create an IAM bucket policy? No. Or enable CloudWatch logs? That's a good one. So if you didn't know the difference between CloudWatch logs and server access logs, I can see why you would say CloudWatch. But CloudWatch, I think, is mainly for monitoring the health of a service, meaning maybe if I want to get some metrics, maybe if I want to understand capacity about a service, get some CPU metrics, that's what I would use CloudWatch versus using server access logs where I'm trying to literally see who accessed my stuff. So I'm going to go with C because I feel like CloudWatch is used a little bit differently in terms of auditing. I feel it in my gut. All right, number 10, what are some reasons to enable cross-region replication on a S3 bucket? Oh, see? And usually, most of the times, if you continue down or start to answer more questions, like as you're taking an exam, because this is something that I do, this is an exam tip. So if you are taking an exam, so you know how before, where was it? Where I couldn't remember if S3 was regional or zonal. If I continue, I might mark it because a lot of the exams you can kind of mark it so you can come back to it later. I will mark it and continue to to do other questions because more than likely you'll get a question that will give you a hint. So it just said, what are some reasons to enable cross-region replication in S3, which means S3 is regional, which means that lets me know that I probably got that question correct. So a little exam tip to continue going. Even if you're stuck on something, like mark it, write an answer just in case you don't get time to come back. But if you do have time to come back, just mark it. So what are some reasons to enable cross-region replication in an S3 bucket? Do we want a backup of your data in case of accidental deletion? Maybe. You have a set of users or customers who can access the second bucket with lower latency. That's a good one. For compliance reasons, you need to store data in a location at least 300 miles away from the first region. Okay. And your data needs at least 5 nines of durability. Okay, wait a minute. What did you ask me? What are some reasons to enable? I feel like all of those are good reasons, no? Okay. For cross-regional, right? Cross-region replication. Okay, so 5 nines of durability just means, and by 5 nines, they mean 99.99999% of durability. I don't feel like that applies here. I do feel like compliance reasons would be good because regions do have to be a certain amount of miles and distance away from each other. So if that is a compliance reason, that's a really good one. And lower latency is also a really good one. So I'm gonna go with those two. I feel like those two make sense. Yeah, I feel like those two make sense. Cool. Number 11, almost there. Your company requires that all of your data sent to external storage be encrypted before being sent. What S3 encryption solution will meet these requirements? Important to know about the differences in encryption services that they offer. So you have server-side encryption with AWS managed keys. You have server-side encryption with customer-provided keys. You have client-side encryption with customer managed keys, or you have server-side encryption with AWS key management. A lot of options here. All right, so your data needs to be encrypted before being sent. So automatically, SSE with customer provided keys, I provide the key. So this one is out for me with AWS managed keys because that means this is not going to be encrypted before it gets to AWS. I'm leaning towards, no, I'm leaning towards B or C. So the reason why I'm going with B is because I remember reading that server-side encryption with customer-facing keys means that I, the customer, encrypt and manage the keys before getting to AWS. I'm pretty sure about that. Yeah, I'm pretty sure about that. Hopefully. We'll see. All right, number 12. You have a popular web application that accesses data stored in a S3 bucket. Okay. You expect that access to be very read intensive with expected request rates of up to 500. See what I was talking about? I had said that when I was going over my notes, that they will have a question that asks you whether or not how many gets per second and if you need to change some things or like what the best practice is against that. So you expect access to exceed or up to 500 gets per second. How can you increase the performance and scalability of S3 in this case? Can you turn on cross-region replication to ensure data is served from multiple locations? You could. Can you ensure randomness in a namespace? That doesn't make sense. Turn on server access logging. That doesn't make sense. Ensure that the key names are sequential. That doesn't, okay, they made that easy for me because I can eliminate these three because that doesn't make sense. So we're gonna go with A. I wish all the questions were, just give me the answer. Like that's great. I like that one. All right, what is needed before you can enable cross-region replication for an S3 bucket? You need to enable versioning, yes. You need to enable a lifecycle rule. I don't think so. Enable static web hosting, no. Create an IAM policy to allow S3 to replicate, yes, objects on your behalf. I wanna say yes. Ooh, that's a good one. So B and C are technically kind of the same, except one is saying a lifecycle rule to migrate the data, whereas this one is like, oh, you need to explicitly create a policy to allow S3 to be replicated on your behalf, which I think it says, I think you have to give permission in order to replicate into different regions. So I definitely think versioning is one of them. And I'm gonna go with D, because I feel like you have to explicitly tell AWS, yes, you can migrate my data. Like they don't do it automatically. All right, number 14. Your company has 100 terabytes of financial records that needs to be stored for 7 years by law. Automatically, when I hear 7 years, I think of Glacier because Glacier is a long-term archiving storage system. Experience has shown that any record more than 1 year old is unlikely to be accessed. Which of the following plans meet these needs in a cost-efficient manner? So this is along the lines of when I was saying that understanding the different storage classes and understanding like how to do a lifecycle management process with storage classes or with data in general is important to know. So to meet these needs of 7 years and that anything after a year is not going to be accessed, you can, one, store the data on EBS attached to micro instances. No, don't do that. That's expensive. You can store in simple storage with lifecycle policies to change the storage class to Glacier after 1 year. Oh wait, not delete the object. We don't want to do that either because you need it for 7 years. So that doesn't apply. Oh, there we go. Delete the object after 7 years. Okay, that's the answer. Because MapReduce doesn't apply here and neither does databases. So the answer is B. Yeah, I hope the exam is like this. I know it's not, but I hope it is. S3 bucket policies can restrict access to an S3 bucket and objects by which of the following? What? S3 bucket policies can restrict access to S3 buckets and objects by which of the following? Restrict access. Oh, what can you restrict access by? Company name, IP address, range, AWS account, country, objects with a specific prefix. Choose 3, what the hell? Okay. I want to say AWS account, definitely. I want to say IP address range, definitely. Maybe? E is out for me. I don't really know how that applies. I'm not sure about company name. I don't feel like that applies either. So I'm going to go with B, C, and D. I'm not sure about this one. I don't remember reading that. All right, almost there. 16. S3 is an eventually consistent, I mentioned this earlier, storage system. For what kind of operation is it possible to get stale data as a result of eventual consistency? So is it a get after put of a new object, which means I'm asking to grab information after I just created information on a new object? Or am I getting or listing after a delete? Am I getting after overriding a put to an existing key? Or am I deleting after put of a new object? So I know it's not this one simply because after writing over an existing key and doing a get, that's automatic. D is out for me because you're not getting stale data because you just deleted. Get or list after a delete or get or put of a new object. So shoot, that's a good one. Because it's a new object, I don't know. Because it's a new object, I'm trying to remember, is that automatic? Is we said it was it's eventually consistent, which means it's delayed. Get or list after a delete. I want to go with B, simply because after you make a change to an object, I'm gonna go with B. I don't know why. There's something that's saying a new object is not going to be eventually consistent. That's pretty consistent, really. 17. What must be done to host a static website in an S3 bucket? Choose 3. You must configure the bucket for static hosting, create a bucket with the same name as the website, enable FTP, make the objects world readable, enable HTTP. So I definitely know you have to make them world readable. Choose 3. Yeah, I'm not sure about the other one, so we're gonna have to make some educated guesses here. So I'm gonna go with, I don't think you need to create it. Do you need to create a bucket with the same name as the website? I don't really know. I don't feel like so HTTP is out because I'm pretty sure it requires or says best practices is to use HTTPS as with anything. So that's going to be out for me. So I'm going to say D. I don't think you need to enable FTP because I don't feel like that should be a requirement. So I'm going to go with A, B, and D. 18. You have valuable media files hosted on AWS. You want them to be served only to authenticated users. You're concerned your content could be stolen and distributed for free. How do you protect your content? Do you use static web hosting? Do you generate pre-sent URLs? Do you use IAM policies to restrict access, or do you use logging? So I have valuable media. I only want it for authenticated users, which means I'm not using static web hosting because that's for everybody to view. Logging doesn't help me restrict access. I'm leaning towards C, which is the only thing that would actually require my users to be authenticated or like roles that I specify. Whereas pre-signed URLs for content, I think that's just for making sure my website is secure, not necessarily. We'll come back to that one. Cool. Amazon Glacier is well suited to data that is which of the following? Choose two. Infrequent or rarely accessed? Yes. Must be immediately available? No. Is available after a 3 to 5 restore period? Yes. Is frequently erased within 30 days? No. So the answers are A and C. All right, last question. Which statements about Amazon Glacier are true? Choose 3. Data is stored in objects that live in archives? Yes. Archives are identified by user-specific key names? I have no clue. Archive time takes 3 to 5 hours to restore? Yes. Amazon Glacier vaults can be locked? I don't know, but I feel like there was another question with vaults, so maybe. And Glacier can be used as a standalone service and as an S3 storage class. I have no clue. Okay, so definitely it's A and definitely C. I'm now choosing between D and E. Can be used as a standalone service. So what I say, A, C. I'm gonna go with E. We'll see. All right, let's go look for these answers. Let's show the sidebar. Oops. Let's show table of contents. I want the answers to chapter 2. All right. I will just highlight whatever I got wrong. Damn, I got the first one wrong. What? Hold on. Oh, see, I didn't know if it had both data and metadata. Okay, cool. So I got the E right, but not that one right. Okay. So highlight it. No, how do you highlight again? Highlight? No. How do you highlight? There we go. That equals D. 2 is B and D. S3 cannot be mounted on an instance like a file system. Oh, I was confused. I was like, is the answer A, B, C, D, and E? No, it's A, B, D, which is correct. Objects are private by default. 4 is B, C, E, which is correct. 5 is C and E. What is this? Versioning. Oh, versioning does protect. I wouldn't think to use versioning as a protection mechanism because if I have different, I can understand it as a redundancy method, or like I can, that's a little bit weird to me because if I have different versions of the same file, right? So say I make minor changes and I have versions 1 through 4. If my version 4 gets deleted and I've made changes, how would I be able to get that data? Like that data is gone. Like version 4 is now gone. I only have version 3. So what if I do not know what version 4 is supposed to be? That's not a protection mechanism to me. But let's see what they said. So what was this 5? Versioning protects data against deletion by storing all versions of the object. MFA requires a one-time code. Vault locks. Oh. Vault locks are a feature of Amazon Glacier, not S3. Okay, that makes sense. I don't really understand about the, like I understand about the versioning, but not really. But I'll do what they say. I mean, I'll go along with what they say. So that means that is C and E. Cool. 6 is C we got right. 7 is B. Data is automatically replicated within a region. Replication to other regions are optional. Aha, I mixed that up. So I believe I remember this question for number 7 was about, oh yeah, the trick of whether or not, what am I talking about? Whether or not S3s are regional or zonal. And I was like, oh, I can't remember. I definitely know it's regional. I definitely know you can replicate it. It's replicated cross-regional, but I guess you have to enable that versus just automatically replicated within a region. So that makes sense. I get that one. There was a little L on my part. All right, 8 is C, 9 is C, 10 is BC, 11 is C. If data must be encrypted, dang, I knew I should have picked that one, client-side encryption. So this one was asking like if you needed to encrypt your data before sending over to AWS, what should you do? I knew it was client-side. I'm not sticking to my gut. 12 is B. Damn, what's happening? Amazon scales automatically, but for request rates over 100 per second, it helps to make sure there's some randomness in key space. Okay, that was one I didn't know. So I'm okay with that. I had no clue. 13, A and D. 14 is B. 15, B, C, and E. So, oh yeah, I didn't know this one either. So bucket policies cannot specify a company name, which I didn't think, or a country of origin, but they can request an IP range, an AWS account, and a prefix. Okay, so I didn't know about the prefix. So that's wrong. That should be E. 16. I'm supposed to choose 2 for 16? Am I bugging? Oh, I can't go all the way back. I was supposed to choose 2? Am I bugging? It did not say choose 2. I'm counting that as a win because I got B. I didn't see it say choose 2. But at least I got one right. 17, A, B, and D was correct. 19, damn, it was a pre-signed URL. Dominique. Cool. Equals B. 19 is AC, which is glacier, and then characteristics of glacier is C, D, and E instead of A, C, and E, which means it stores data in archives, which are contained in vaults. Archives are identified by archive IDs, not key names. All right, that makes sense. So it's really important, I guess, or for me, understanding the different characteristics of Glacier versus S3. So like Glacier has a vault, but S3 doesn't. And S3 does key names versus Glacier does system created archive IDs. So again, so many characteristics between all of the different classes and all of the different services, which is important to know, especially as you're taking an architect exam, because if you're architecting something, you should know, hey, like what security mechanisms comes with this service, what retention periods come with this service, what XYZ come with this service. So totally get it. I'm gonna go back and review later once I do finish doing my notes. This was a good study session. I actually really like the study session. This was a good session today. I'm glad I did my notes in the slide deck version. So I will share that out. Like I said, I will figure out a way to get that out to people once I'm finished with it. Or maybe I can share it out now if you guys just don't mind that it's not, no, I don't like putting out half-ass content. So or I'll break it out. So I finished chapters 1 and 2. So maybe I'll break that out and put it in the folder. So you can just access 1 and 2, and then I'll put 3 and 4. And then when I'm finished with all of the chapters, then I'll consolidate everything into one large deck and go like that. I'll figure it out. I'll figure out a way to get it to everybody. But if you've joined, thanks for watching. If you're watching after the fact, I hope you've learned something. And I'll be back. So I've already done, now this is chapters 1 and 2, half of 3. But 3 really matches with 4, so I've already done 4. Then we'll get into more stuff, some 5 after the Christmas holiday. So thanks. Bye.